Welcome everybody. Welcome to this introduction into one function in Excel, which is called the Excel solver. You can use this function to solve some optimization problems. It might be a maximization problem or a minimization problem. And here in this introductory part, you'll get two examples. One is optimization without a side constraint, and one is related to an optimization problem with a side constraint. So we are looking at one company. The company is producing something, and the demand relationship is as follows, that there is a negative relationship between the price and the quantity. So a downward sloping demand relationship, the price is equal to 100 minus 2 times Q. Variable costs are equal to 20, fixed costs are equal to 200, and the assignment question is that you should maximize profits. In the first step, it always makes sense to write down the relationship for profits. Profit is given by revenues minus cost. So, revenues are given by price times quantity. Then we have to subtract the cost. We are subtracting here the variable cost and then the fixed cost. Let's plug in the information we have, like we have information for the price relationship. The price is equal to 100 minus 2Q, like the term in brackets symbolizes the price, times the quantity. So the first part, these are the revenues. Then we subtract the variable cost, so 20 times the quantity, as well as the fixed cost of 200. So the profit function is given by the first equation. We have to compute the first derivative. We have to differentiate the profit function with respect to Q, and then set the first derivative equal to 0. Let's do that. We get 100 minus 4Q. This stems from the revenue function. So marginal revenues are given by this term, 100 minus 4Q. And then the marginal costs are given by the variable cost of 20. When we solve this relationship for Q, it is the case that Q is equal to 80 over 4, or the optimal quantity is equal to 20. The optimal price is given by this relationship. We have to insert the information that the optimal quantity is equal to 20, so that we get the information that the optimal price is equal to 60. The size of profit is equal to, like first we have to compute the price times the quantity minus 20 times the variable cost minus the fixed cost. So we get here the price is equal to 60 times the quantity, so that revenues are equal to 1,200. And then we have to subtract the variable cost of 400 and the fixed cost of 200, so that in the end the profit is equal to 600. Now I would like to switch to Excel and show you how you can use the Excel solver to replicate these solutions. In the first step, I set up this Excel sheet here. In row number 3, I plug in the quantity, and right now in cell number E3, I just plug in a random number, let's say 2. In the end, this is the changeable cell, so Excel should change the quantity, and then everything else what follows will also change. The price is given by this relationship, 100 minus 2 times the quantity. So 100 minus 2 times E3 gives you the price, and now the price should be equal to 96. Revenues are given by price times quantity, so E4 times E3. The costs are given by 20, is equal to 20 times the quantity, So 20, these are the variable cost times the quantity. And then we also have to add like the 200 variable cost. So here is one slight mistake. Of course, we don't have to subtract the fixed cost. We have to add the fixed cost. So right now, the quantity produced is equal to 2. So the costs are equal to 40 units variable cost and 200 units fixed cost. Let's compute the profit. Profit is given by revenue minus cost, E5 minus E6. So the problem is set up, and now I will ask Excel to optimize this relationship. I have to find the solver, which is given under data. Then the solver is given here. The objective is given by the information in cell number E7. So the profit should in the end be maximized. We have to put we have to put the dot here at the maximization problem by changing cells. Here, Excel should play around with the quantity, and then in the end, the profit should be maximized. So now we can press the solve button, and hopefully in the end we get the result that the profit is equal to 600 units. Great, let's round the numbers. So the quantity, optimal quantity is equal to 20. The price is equal to 60. Revenues are equal to 1,200. Costs are equal to 600. Profit is equal to 600. So Excel can solve this maximization problem very, very fast. Let's have a look at the second problem. So let's try to talk about optimization with a side constraint. And there the outline is as follows. A company uses the following production function to produce cars. This is the production function Q is equal to K times L. The price for 1 unit of capital is the interest rate, and we assume that the interest rate is equal to 10. The price for labor is the wage rate, and the wage rate is equal to 20. Now the assignment question is, use the Lagrange method and minimize cost to produce 20,000 cars. So here the side constraint is that we should produce 20,000 cars, but we should optimize cost, we should minimize cost. The Lagrange function is set up in the following way. In the first part of the Lagrange function, there is a function which has to be optimized. And then we add the so-called Lagrange parameter, we add a lambda, and then in brackets we have the side constraint. In our assignment, it is the case that we should minimize the cost. So in the first part, we have here the cost function. Cost is given by 10 times the number of capital units plus 20 times the number of labor units. Then we have here in the second part the side constraint. We should produce 20,000 cars by the production function K times L. Great, when we have the Lagrange function, we have to compute the three different first order conditions. When you look at this Lagrange function, it is a case that we do not know K, we don't know L, and we don't know lambda. So we have to differentiate with respect to K, with respect to L, and with respect to lambda. Let's do that. So when we differentiate with respect to K, we get 10 minus L times lambda. And this should be equal to 0. When we solve this relationship for lambda, we get this relationship lambda is equal to 10 over L. Let's differentiate the Lagrange function with respect to the labor units. We have 1L here and 1L there. When we differentiate with respect to L, we get 20 minus lambda times k should be equal to 0. When we solve this relationship for lambda, we get lambda is equal to 20 over k. In the next step, we differentiate with respect to this lambda here, and then we get once more the side constraint. So when we differentiate the Lagrange function with respect to lambda, we get here the side constraint that we should produce 20,000 cars. When we combine these two expressions, then it should be the case that these lambdas are the same, so that 10L is equal to 20K. Let's write that down. 10 over L is equal to 20 over K. And then we solve this relationship for K. So K is equal to 2L. On the next slide, we can already come up with the overall solution. So we have to insert this relationship, 2 is equal to 2 times L, into the third first order condition. So instead of this K here, we are inserting 2 times L. So we get 20,000 minus 2 times L should be equal to 0. Hence, we get 2 times L squared is equal to 20,000, or L squared is equal to 10,000. When we divide this relationship by 2, we get to equation 13. When we take the square root, then it is clear that L should be equal to 100. When L is equal to 100, K is equal to 200. The number of cars produced, of course, is equal to 20,000. This is our side constraint. And the total cost, this is the most interesting answer to our question. Total costs are minimized, and the costs are equal to 4,000 currency units. Let's also try to replicate these results in Excel. First of all, we have to plug in some random numbers for the number of capital units and also some random numbers for the number of labor units. So I just plug in a 2 here and a 2 there. Later on, Excel should play around with these numbers and should optimize this function. In the next step, we can compute the output in case that we put 2 units of capital and 2 units of labor in the production process. Then the output is given by K times L, so E4 times E5. This gives us the output. So right now the output should be equal to 4, but in the end it should be the case that the output is equal to 20,000. This is our side constraint. The cost right now are equal to 10, like the interest rate, times the number of capital units, plus 20, the wage rate, times the number of labor units. So the costs are right now equal to 60. And the target cell is cell number E7. So in the end, this number here should be minimized. And hopefully this is equal to 4,000 currency units in the end. So let's once more ask Excel to solve this problem. Like I press on data and then here solver. The objective is the cell number E7 where we find the cost. Now we have to set the dot here at the minimum because it's a minimization problem. Changeable cells. Changeable cells are given by E4 and E5. And then we have to set one side constraint, and the side constraint should be that this cell should be larger or equal to 20,000. So we want to produce at least 20,000 cars. So the objective, this is the cost cell should be minimized by changing variable cells. Changeable cells are given by E4 and E5, and then we add this side constraint. Now I press the solve button and hopefully we get the optimal result. Great, let's round the numbers. So K is equal to 200, L is equal to 100. So with 200 units of capital and 100 units of labor, we can produce 20,000 cars, and the cost is equal to 4,000. The costs are minimized. So we were able to confirm also the optimal result of the second problem. So thank you very much for watching this video on the introduction of the Excel solver by looking at two different assignment questions. The first one was an optimization problem without a side constraint in the form of a profit maximization problem, and the second problem was an optimization problem of the form minimizing cost but with a side constraint. Thank you very much. Have a nice day. Bye bye.